But as of now, so the prompts, so all these instructions, how this, so let's just say ChatGPT. When you prompt something to ChatGPT, so basically how that prompt is being read by the LLM and how it is trying to respond. For that, we needed to understand like three different concepts: embeddings and transformers, right? Where we looked at like tokenization. So basically, we have to understand what the token means. So these large language models can't directly read English text. Okay, so they understand the language of like tokens. For each word, it is trying to make sense out of the words that's been given as a statement. Okay, so each individual, not the word, but the part of a word or maybe the whole word, which makes sense to that model, could be considered as token. And this tokens could be different for different models. Okay, depending on the training data set. Okay, just a second. Okay, so this was in like generic formula where let's say what each English word could have like 0.75 words. Okay, each token. Okay, so let's just say there are 4 words, so it could almost have like 5 tokens, right? So we looked at like with the tokenizer website from OpenAI, we looked at how tokens are being created. Okay, when we remove the space, the tokens, it was trying to make sense out of the word that's been given, right? So we looked at this and we looked at like why do we need to understand the tokens, because the cost of the API, and also we understood what the context window means, right? So context window in simple words means like how much can the memory of that particular model for a session. Okay, so how much can it remember? Usually it is 128 to 128K tokens. Okay, but this is not same as like attention window. Context window is different from attention window. We discussed that, and then we went into vector embeddings. So what are vectors? We try to understand the dimensions, the concept of dimensions through student marks one, student one, like different subject marks, and the third subject, right? With this example, we understood like what are the dimensions and how these dimensions are presented into like mathematical form, and how each model considers its own dimensions. Okay, there could be like 800 to 8,000 of it, the dimensions, and every time a word comes in or a statement comes in, this mathematical representation called vector are being generated. This is nothing but embedding also. So vector and embedding you can say to be like same. Okay. So once these embeddings are generated, so now it is trying to match the similar content from its knowledge base and trying to make sense out of it and try to answer. Okay. That's why understanding this vector embeddings becomes essential. And how does it calculate like these words, these coordinates? How does it calculate is? So whenever these transformer architecture, these LLMs are subjected to like input data, right? So data for training. While training, these depending on whatever the training has happened, whatever the data is being fed for that training, these coordinates are created. Okay, so that's why this embedding for from a single model could be different for embedding from the other models. Okay, let's just say OpenAI 4.0. So if it generates some embedding, okay, this wouldn't be same for OpenAI like 3.5 turbo or 3.5. Okay, that could be different. And then we understood with this simple example, that is supermarket analogy. Okay, so if you want chips, we will go to like snack section in the supermarket, right? I won't go into groceries and check for it. So similarly, when these embeddings are created, so it exactly knows in its knowledge base, in its like space where the information related to this particular embedding, this particular query is being provided. Okay, so there it looks for it. It looks for the content within the snack section to look for chips and tries to respond. The technology we understood. And today, here we stopped yesterday. So we were trying to understand transformer architecture here in this platform, but we stopped it right here, right?
One small question. So the tokens that you have told that you have said 128K.
Yes.
So it contains a limit, even though if you have mm, if you work professionally or you are practicing or any kind of a platform, or it varies. Does it shows the variation?
Okay.
Limit increases, or it stays in that particular limit?
Sure. So, 1 to 8K tokens is usually standard for all the LLMs currently, but this is not like always the case. Okay. So let's just say you are using a pro subscription of OpenAI or a pro subscription of like Gemini tools. Okay. So there the context window could be increased. So it may be 256 or 512K tokens or more. Okay. So depending on what how much you are paying or what is the plans, this could differ. But usually for any large language model, the standard context window is like considered to be 1 to 8K tokens. Okay.
Okay, okay, okay.
Okay. Sure. So shall we start with like today's session?
Yes, yes.
Today's part of it at least. Sure. So yes, for these large language models, I said they are built on transformer architecture, right? Okay. So they are built on transformer architecture. So what's this transformer architecture is about? Like, what's so special about it? We had RNN, right? So we discussed RNN yesterday. Which specialized in like orderly. So wherever there is an orderly data, this was working good already, right? It may be stock, it may be word prediction, next word prediction, where there is an order. Okay. So
Right.
this was working good already. So why the need of transformer? Okay. So as the deep learning started like 2010, okay. So RNN CNN ruled the deep learning, the AI world like anything until like 2017, where the transformer architecture this transform architecture was introduced. The paper was published from Google where it introduced the transform architecture. So what is the different like of course right. So if there is some research, something has to be different there. Something has to be improved there, right? So what improved here is so the flaw with the RNN was so let's just say there is a statement. Let's consider this. Older AI models read the sentence word by word and forgot the beginning. So this is the explanation. But let's just say the RNN was reading this. Okay. So it used to consider the older AI model read a sentence word by word. So as it read like 2000 words, such words. Okay. If the input is like 2000 words, it would essentially forget what it read earlier. Okay, because there are so many things to handle here. And let's just say I'm saying my name is Arya and I have given like thousands of words of my introduction, my achievements. And then later I say, I was great, so and so, so and so. Okay. So there, when I say I, so what it has to refer to? It has to go back to like thousand words, go back thousand words and need to look into my introduction. That is, I am Arya. Correct? This link used to be broken in this RNN. Okay, it was good with like orderly matters, but to refer back and to link the words, it was a flaw for RNN. Okay, and this transform architecture, what it introduced was so let's just say there is such word. So whenever this statement goes, so I am Arya, the introduction goes, and there are like thousand words of introduction I have given, and then I say I am so and so. I just start with it. So there it when it come across like I, it directly creates a mathematical connection between Arya and I. Okay. So there it is trying to understand that I is nothing but Arya. He's speaking about himself, this Arya. Okay. So for all the words which could be like related, okay, no, related in the sense which could refer back to something. Okay. So for all those, it is to give this attention. So Arya and I are linked. So this is the attention that's been given, right? So this transform architecture, what it did was this link, it used to hold these links pretty well. And due to this, the era of LLM actually came in. Okay, so all the LLMs are built over this transformer architecture. Okay, uh, yeah. So yes, here is a classical example. The animal didn't cross the street because, yeah, here we are referring like it, right? So we know that it means the animal, right? So as we know the English, we know that it here refers to animal. Okay, but it is not understanding the English anyway, right? It is understanding the mathematical representation, and there was no link between animal and it here. Okay, so this transform architecture, what it gave is like it created a link between. It gave attention to this, let's say part one and part two, and it is creating a link between these two. And this become a major uh, improvement into RNN. So such that we could train models much more efficiently and much larger data set could be like provided to it, and it could remember everything, right? So this was like the transformer architecture. So we are not going in depth with the technical details of transformer architecture because, of course, we need to understand like what the transformer architecture is about. That's it. The mathematical representation behind it or the mathematics behind it, we may not need it. So we will not explore much on it. Okay. So the basic difference between RNN, CNN, and transformers are good enough already. Fine. Yes. So now LLM models are built. Okay. So there are like three kind of models. Okay. First is proprietary models, GPT-4. All the OpenAI GPTs, right? They are usually closed source. Okay. So when we say closed source, what does it mean? It's a proprietary model. Okay. So what it means is that a separate private company has trained this model with the input data. Okay. It has trained this model. So this model uh, is ready now. And as a third party person, I can work on this model. I can use this model, but OpenAI would ask me for to pay for it. Okay. In some form, maybe in the free for all the free ChatGPT versions, right? So it basically like lets us pay it by providing the training data. So whatever we are interacting, so it is observing it and it is later using it for training its models. Okay, so that's how we are paying it. It's not totally free actually. But if you are getting like premium models, okay, let's say some corporate wants to use this OpenAI models, it pays in the in form of like money to OpenAI, saying that you shouldn't check at my data. So I'm using your model, okay, but my data has to be secured. You don't have to train your model with my data. You can't. Okay, that's the contract that's been made. So all these plans, OpenAI plans for corporate, is because of this own reason. Okay, they don't want to share their data. But the problem with proprietary models is they are good. You're right. They are proprietary models. They are private models, but still they are good. But the problem here could be you can never know. Let's just say my company is ABC and I have taken a plan from OpenAI. Okay, I'm sharing my sensitive data. Okay, so you never know whether OpenAI is keeping my data or deleting it. Okay, although the contract says it has to delete my data, I never know. I don't want to believe the other companies, right? So that's the problem with proprietary models. So we have like open source models. Okay, so in the demo sessions where I showed you like my local GPT, local LLM models, right? So this was one of the models, Llama 3. Okay, so these are like free of cost. Some company has trained this model. Okay, so it has given the data, given put data, and it has trained this model. And now this company has made it open source. Like anybody can just install it into their PC. Okay, they can install it and they can train if they want to, or fine tune if they want to, or use it directly. Okay, so this in a proprietary model, OpenAI is giving us an API to interact with its model. Okay, but we are not providing like we don't need any hardware in order to run this request. But in open source models, we may need hardware. Okay, my computer must have GPUs. Okay, my computer should be strong enough to run these models. Okay, my computer should have storage to actually run these models. Okay, these are my hardwares. They have trained the model and they have given it for free. but to use it, I have to invest my own infrastructure, right? So these are open source models. So what's the profit here is basically your data is not leaving your computer. It's all with you, and the control of this particular model is like within your grasp. Okay, so you can control this model how it if you can fine tune it, you can fine tune it. So we will check on what fine tuning is. Okay, but yes, you can train more data on this. Okay, and improve this model, or you can use this model any way possible. Okay, that's your personal. Once the model is open source, there are so many open source models, and here we have to pay it in some form. We don't have to pay it. We are paying it through our hardware. Okay, our electricity, our hardware investment, right? So that's the difference between like open source and proprietary models. We never know what's the weight. So usually for all the large language models, right? The important factors are weights and biases. For all the deep learning models, not just the LLM, deep learning models, weights and biases contains like everything. Okay. So when I said for every deep learning model, let's just say there are so many hidden layers and there is an output layer. So I said there could be input layer and there could be output layer. All these are hidden layers, right? So here the training is happening. We are providing like a whole internet data. We are providing it, and somehow it is making sense out of it, and it is training the model. Okay. So they are all interconnected. So every output of a single node is an input for the other node, and finally this output layer is providing us with an output. Okay, it may be next token prediction or next word prediction, right? So whenever this training happens, right, there is something called weights and bias. These are two variables which are configured every time the training happens. Okay. For each node, W1. So this for node one, it could be weight one and weight two, bias one. And for the node two, it could be weight two and bias two. So how it is it? So what's the training means is basically configuring this weights and bias is what the training is actually doing. Okay. When we say the model is being open source, okay. So they have trained the model and the weights and bias for each node is already fixed now. Okay, it's trained, so it's fixed. So now they are giving it for free. They are just exposing this weights and bias of each node openly. Okay, that is what open source models means. Okay. So how these weights and bias are figured out? They are figured out based on the training data. Okay, that's why. Let's say I'm creating a machine learning. So let's say I'm creating a large language model where the input data never contains something about India. Okay. Let's say whatever I'm training the input data never mentions India as a country or something. Okay. Never mentions its culture, never mentions its name or geography or origin, nothing. No information on India and everything else is being given. So if I ask this LLM, tell me about India, it definitely wouldn't know about India anyway. Okay, because the source of truth for this large language model is whatever the input data has been given, what it is trained on. So the weights and bias, they are fixed into these particular neurons, doesn't contain anything regarding India. So it doesn't know what India is. Okay, the only source of truth is the input data, and input data never contains something on India. Okay, so the India, it doesn't understand what India is. So basically, okay. So yes, so this was a generic example. Okay. The more generic example would be like, let's just say for the snakes, we are only providing with venomous snakes every time the training data happens. Non-venomous snakes, although they are 95% of the snakes are non-venomous, we don't mention it anyway for in the training data. So this model will start thinking. So whenever it needs to respond, it will always respond as snakes are venomous. Okay. So for every snake, it's a venomous. Is the default thinking for this model now. Okay. So whatever the input data is, that is the only source of truth it understands. It is not connected to real world. Okay. So that's proprietary models and open source models. Now fine-tuned models. So this is, let's just say Google trained a model with its, for training a model, it needs like huge, not the consumer, but the industry level GPUs. Okay. So let's say Google has trained this model and it has decided to make it open source. Okay. Now we have this model M1, which is open source. Now we can install it into our computer or some corporate. Let's say I have a company, okay, Arya Private Limited. So now I want to use this model, use the training data, but I want to make it efficient for, let's say, to act as an like my particular chatbot or a AI coding assistant, let's say, okay, or an like a creator kind of thing, anything, okay. So now what I will do is, so the weights and biases are fixed because the Google has given a generic data and the generic model is created. So M1 understands the language now. It is a language model, okay, and it is a large language model. That's why it understands so many things in generic sense, okay. If I ask like tell me about science, it would answer it. Tell me about maths, it would answer it. All the general knowledge, it has got it now. But let's just say this Arya Private Limited, I want to convert this model into my AI coding assistant. So how I can do it? So I will not retrain the whole model, but I will inject with more input data. Okay. And this input data contains all the repos from GitHub, okay, where codes are being given, right? So now this model updates its weights and bias. So whatever weights and bias earlier was there, it used to understand the language already. Now it tries to understand the code, and these weights and bias changes like WI and BI. Okay, there is a change in weights and bias, and now I have my own model. Let's say MA model area. Okay, so this is trained on coding data sets. Okay, training a code trained on like coding data. Now I can use this as my training assistant. Sorry, AI coding assistant, because now it is exposed to most of like coding data. Now it understands the code and responds back with the code efficiently. Okay. So here what we did was like we took something basic, something generic, and we fine-tuned it to become like something specific. Okay. It already understood like the language, it understood like how maths work, how the code works in the generic sense. But by exposing it to like a lot of code, professional code, we actually made a model area where it is an AI coding assistant. It can act as an efficient AI coding assistant. It is still a generic model, but it is specialized with AI coding assistant, right? So there are set of models which are like for language. There are OpenAI is good, and there are so many models within the OpenAI where it is good for language. And for coding, we have Claude, okay, Claude Code and everything. All these models are very good for coding. And let's just say for analysis, reasoning models. So DeepSeek models are good for like reasoning kind of thing. And OpenAI 5, all these models are like thinking models. They are reasoning models. Okay. So there are different kind of models. So how they are trained is like depending on the training data set, these models are fine-tuned basically. Okay. A generic model could be converted as expert into some subject model. Okay. So that's what like fine-tuning means. So yes, we went through like a lot of stuff here. So any doubts?
No, no, so far clear.
Okay, that's good. That's great. That's good. Okay. So what do you think? Like, can we? Uh, you want to download an offline model for yourself? We
Yes,
can do
yes,
it as a part of this course.
absolutely.
Sure. I will just stop sharing my screen. I will put some code into the chat. Okay.
Okay.
So you can open PowerShell. So what's the configuration of your laptop? It has got GPUs.
Um, I'm not sure, but I usually use LLMs.
You mean in offline mode?
No, no.
Okay.
If you want me to share my screen so that if you can understand, because I told
Okay.
you right, I have no idea about all this.
Okay. Yeah, you can share. You can share your screen. No worries.
I don't see the option here. Okay, share.
Because depending on the laptop configuration, the model you can download differs actually,
Okay.
because the size of the model could be different, right? So depending on how many parameters the model contains, the size depends on it, and how much can your laptop bear. Depending on that, you have to install the models, or else it may crash your laptop. So no harmful laptop, no harm for laptop, but yeah, things may stop working.
Okay. I hope you can see my screen.
Okay. Yes,
So,
yes, it's
what am I
visible.
supposed to do?
So
Did you share
let's
the link?
just sorry.
Did you share the link in the chat?
Yes, yes. So just open your taskbar just for
Hello.
open your task manager.
Hello.
Yes. You can type like task manager.
Okay.
Yeah. Please open this.
Yeah.
Just maximize it and go to processes. So there in the left, in your left, there are windows, right?
Yes.
So just go there performance. Just below that, three bars in the left upper corner. Yeah, click on that. The second one.
This one. Okay.
Yes. There, here you can see you have got NVIDIA GTX 1650 graphic card. Okay.
Okay.
So you can click on it actually. GPU one, it's visible there, right?
Okay.
So we got like 4 GB of memory. Great. So we can definitely run the models. So yes,
Mm-hmm.
now copy my link which I shared.
Sure.
Yeah, copy the whole thing. So here, yeah, you can open this. Yes, now paste the whole message which I have sent you. Yep.
Enter.
Just enter. So now it is downloading Olama. Okay.
Okay.
Meanwhile, you can copy the second message which I have sent in chat.
Mm-hmm.
Just copy it and type it in the same PowerShell. After this download,
Okay. It's 100%. It showed 100% here.
just a second, maybe it will come in.
Okay.
So yeah, this will take a while. No worries. Okay.
Mm-hmm.
And just to let you know, don't worry if it crashes. Okay. Sometimes. So whenever we are in video calls in our laptops or some meetings, okay,
Mm-hmm.
the GPUs could be used to process these. Okay. So that's why
Sure. Sure.
if 4 GB of the storage is not available for these models, they may crash. Okay, just you have to do is like just restart the computer and everything will be fine now. Okay.
Okay, okay.
So if it stucks or else everything is good, no issues.
Mm.
Yeah, you can stop once it's done. Just put up that code and you should be seeing like Llama 3. It should install the Llama 3. It should download the model first and then run it. Maybe you can ask me doubts like later if it doesn't go well. Okay.
Sure, sure. Yeah. I think it's
Yeah.
still showing installing Llama.
Yes, yes. It will take time. It will take time. Don't worry.
Okay, okay. Should I
Yeah.
stop sharing?
Yeah. You can just minimize this window and stop sharing. Later you can try
Okay.
it and let me know how it went.
Oh, sure, sure. Sure.
Don't cross it. Like just minimize the window.
Yeah.
Sure. Great. So yeah, once it's done, once the second code is done, it should install the Llama 3 model from the internet,
Mm-hmm.
and then it should be available for you for offline. Okay, then you
Okay.
can interact
Okay.
with it, I guess.
Sure. Yeah.
Uh, yeah. So once you don't want to like use that model anymore, what you can do is just a second. What you can do is you can just say /by BYE, and that should end the models like usage. Okay. So this command olama run llama 3, right? So if a model is available for you, this llama 3 is
Okay.
available for you. Sorry, looking at like my screen, is it visible?
Yes, yes, it's visible.
Okay. So when you run this command, so llama 3 should be available for you. It should be like you can write up whatever the text you want and it should respond back. Okay.
Okay.
So you can install multiple such models, not just a single model. You can list out like multiple models and you can choose which one to run every time you want to run. Okay.
Mm-hmm.
In order to stop this model to from working, what you can do is type /BYE and that should stop this model from working. Okay.
Oh, okay, okay then. Yeah.
Okay. Fine. Great. So yeah, so what's the help of this is like you don't have to invest on tokens. So in the second demo session, if you could remember, there
Okay.
my Google tokens expired, right? I hit the token limit,
Okay.
so it didn't respond to me. So such
Okay,
problems
okay.
won't be happening if you have like your model in your local.
Correct, correct.
Right. So yes, so any questions until now?
No.
Okay, sure. Great. Yes. Shall we move ahead? So this would be like last session, last PPT we'll be going through. And once we complete this, we will actually complete the model one, where we were trying to understand what AI is about, what the large language was like all about. Okay. So yes. So however you look, so what these models are doing is like they are actually trying to predict the next two tokens. Okay. Let's just say there is there could be story, the man, the world, uh, maybe some place, the Paris, the humans, animals. Yeah, right. After there could be many words that could fit in. Correct. So, am I audible?
Yes, yes.
Okay, sure. So yes, so there are like many words that could fit in. So how does our model decide which one to use? And so after this word, there could be many words. So let's just say the story is been chosen. The story. Now the story is could come, the story was could come, the story has been could come. right? The story ended could come, the story started could come, right? These are words again, English words, right? So now it has probability like there are like multiple options among which one is chosen. The story is maybe chosen. The story is let's just say good could come, better could come, could have been better could come, or great could right. So there are many words again. So at any point of time, the next word could be like there are set of options among which a word could be chosen, right? So how the model is choosing these words? This is completely on probability. Okay. Okay. So this is completely on probability. Depending on whatever, let's say we have got the illusion. These two words have been given already. So the third one, how the off is selected is depending on these two words and the intention of like what's being generated, what's being asked. Okay. Let's just say I've given the OpenAI or Gemini the query that I have to discuss on how the AI actually responds intelligently. Okay. Now it is creating this PPT. Now it is creating this statement. So how it is saying the illusion of intelligence, right? So it is considering my query. Okay. It is first considering my query, what I'm asking. So it is creating a vector representation of it. And then it is trying to get to its knowledge base. Okay. From there it is picking up some content. And depending on all these, now it has got a set of words which it can choose. Okay. So word one, word two, word three. Depending on the probability of which word would like could be better here. The probabilities are arranged and it would select one. Okay, let's just say word two is selected instead of word one. So the next we have set of word one, word two, word three, set of word n probabilities. And depending on the user context, that is query, depending on the knowledge base, and depending on the word chosen initially, word two, this word among these n words, some word is chosen. Let's just say word three. Okay. And next, there are set of possibilities, possible words, word one, word two, word three, depending on the query context, depending on its knowledge base, depending on these two words that's been chosen, the next word is chosen, right? So how we speak, like I'm trying to communicate in English, right? So how do I communicate? So basically, I'm trying to say something, and I'm trying to think of like how I could say this using the words that's been spoken already, right? To make sense out of my English, correct? So similarly,
Yes.
these large language models are actually predicting the next word. Okay. So instead of using the word, we should say it to be token. Okay. Because LLMs don't understand English at all. Okay. It understands set of tokens. Tokens are nothing but the English words which make sense to that model. Okay. But from LLM's perspective, they are tokens. They are not words. And every time the generation happens, it is trying to predict the next token, next possible token. So that's why in the word, let's just say this LLM is generating the word intelligence. It may generate me first Intel. Okay. Intel, it may generate. And this is the first token for it. And it may generate agents, this second word, as a second token. So for us, it is a single word, right? So for that particular model, Intel could be the first token generated, and then it may generate agents that making intelligence. Although we are looking at intelligence as in like how we know English, but for the large language model, it is creating the next token. It is just generating the next token depending on the query, depending on the knowledge base, and depending on like what it should respond, how it is optimized, right? And this simple process is actually what giving it a power to fake this intelligence. Well, I can't say it to be like faking the intelligence because that's how we show our intelligence. That is what actually the intelligence means. This is what is enabling the large language models, which were trained to predict the next two tokens, are showing the intelligence characteristics. Okay. So did I confuse you with that, with those all those words, or did it make sense?
No, yeah. The thing
Great.
is, so LLMs uh, predict on the basis of embeddings or something.
Sorry.
These LLMs predict next words on the basis of embeddings.
Right. Not the embeddings. Embeddings is how it actually remembers the things, like how it actually checks on what is relevant and what is not relevant. Okay.
Okay.
So it has to. So let's just say uh, the query could be, so how AI understands. Okay. A simple Google kind of statement, right? A statement which could be like Google, right?
Mm-hmm.
So now this particular query is converted to embedding. Okay. Embedding means, so every query or the every output is a mathematical representation, right?
Right.
So depending on this particular query, so some mathematical representation is chosen. Let's say xi, yi, zi, ai, bi, anything. Okay. All these variables are being chosen. Like this is the mathematical representation of my particular query. Okay.
Yes.
Now it considers this, it reads these coordinates, and it's try to think of like whatever the related content it has got. Okay.
Mm-hmm.
In the training data. And then with that particular data, it is trying to generate the first token first. And then it is trying to, until the answer is completed, until there is an physical limit over how much tokens it has to generate. Till then, this token generation continuously happens. That's why you may have seen, like whenever you are asking some simple question to ChatGPT, it brags it about anything, like it starts bragging about that answer, right? Until
Right.
you actually instruct it to like use less tokens, or you answer in very crisp voice, or let's say summarize the things. It usually brags. It tries to create like as number of tokens that it can generate. Okay, that's the tendency of this model because they are trained to do so, right? So now this token one is generated, and depending on all these, whatever the context we have, the query and the knowledge base and the word one predicted, word two is predicted. Okay.
Right.
So, this prediction goes, and somehow uh, we get what we need, the answer. Okay.
Correct.
So as said, even the deep learning models and few of the complex machine learning models are actually black box models. Okay, we don't know
Okay.
how internally it actually works. If it answers to a particular question, we don't know how that answer came in, what the pattern or the formula that's been applied there. We don't know what it is.
Mm.
And these large language models are definitely black box models because they are part of like deep learning models, right? So this is how, in general, this is how it should be answering. But if you give an exact model and if you give the same input, the output generation, we never know how that output came in. Okay,
Okay.
this we need to like remember. It's kind of like
Mm.
a note to remember. Yes. Any doubts
No.
here? No, right? Can we move it?
Yes.
Okay, sure. So here it is all about the next word prediction. So by predicting the next word, so depending on how accurately the next word is predicted, or the next token is predicted, right? It simulates what actual thinking is, right? So that is how we as humans actually think. We try to speak of something, our ideas, and depending on the words chosen previously, we try to figure out like what to say next, right? Yes, so that's what statistical autocomplete. We learned that the models map text to vector spaces, but how do they write paragraphs? Like an LLM does not think, it is essentially a highly advanced version of autocomplete on your smartphone. So the Google keyboard example we took, right? So they are saying like it is an like very efficient next word predictor. Okay, it looks at the previous words in the context window and calculates the mathematical probability of what could be the next word, and it repeats the process until the tokens are exhausted or the sentence is finished. Okay, so I explained the whole thing beforehand, so it's nothing more to explain here. But yes, we have to understand this particular thing. That is, it is not actually understanding whatever we are saying, or it is not understanding what it is trying to say. It is just generating the next token, next possible probable token, depending on its knowledge base. Okay. Uh, yes. So hallucination. You remember in that demo session, so we asked our local LLM to act as an customer service agent, which doesn't give discount. Correct?
Yes.
Remember this session?
Yes.
So here, as we instructed this, and later when I asked the question to that particular large language model, that when do you open? Right? We gave this query and it responded back with set of yeah, information. That is, we open by like 10:30 and we close by 7 o'clock, and we have all these menus. We have all these dishes. We are expert into this. So we were basically asked it to, like, the system prompt was to act as a restaurant customer service, right?
Right.
So we haven't given any information regarding like what our restaurant name is and what are the dishes we prepare, or what are the like timings, right? But still, it is trying to respond back, right? So this is nothing but hallucination. So basically, depending on whatever the data it is trained on, there the data of restaurants could be given, right? So it may have been trained on like data of restaurants. So whatever the usual restaurant timing is, it just said that timing, whatever the usual dishes are, depending, just it just listed those dishes, right? It is trying to convince itself that it is a restaurant customer bot, and it has got like all the information. Since customer service bot, we usually have like all the information, right? So this was not explicitly, this information is not explicitly provided, but it somehow simulated this thing. So this is what hallucination is. What we have provided, depending on which it has to answer. But since we haven't provided anything, the LLMs are just predicting the next word, and it has tendency to, instead of saying like I don't know, it has tendency to actually try to answer it somehow. It just want to complete the sentence, the replies. Okay. So that's why it gave this hallucinated answer for my query. Okay. So this could be dangerous. So let's imagine in the training data, I'm trying to train an LLM. Okay. So I haven't trained this model to be like a medical expert. Okay. So this is a general model which has got all the information available on the internet. And it is also fed with the information where certain websites which oppose, let's say, English medicines, or which questions the authentication of these medicines and all this. It has been exposed to that training data too. Okay. Let's just say there is person A, P1, who is trying to ask my model, so what is paracetamol used for? Okay. So we usually know it's an antibiotic. Okay. So whenever there is a fever or something, we just take the paracetamol. So as simple as that, right? It's not a complex, very serious tablet. Okay. But still, since it is exposed to all this chaos in the training data, where they are opposing the use of like English medicine, they are questioning everything the English medicine does. So now this model is actually creating the stuff to like be abide by this particular training data. Okay, it has convinced itself that English medicines are bad. My model is generic model, but still it is being exposed to this particular content, and now it is trying to convince the person one to actually not use paracetamol. let's just say it's not about paracetamol and some cancer patient try to Google something. Okay, this could be like serious allegations, right, on the Google, because the OpenAI chatbot, ChatGPT just suggested this, or the Meta AI suggested me this, and I did it, and it got me like hurt. Okay, they can put up a case, and they can go against the company, and the company has to pay, right? It's a loss.
Correct.
And for the same reason, the AI quality engineering comes in. Uh, that I have already explained. So we have to. Uh, so although there is it is exposed to like misinformation. Now it is trying to hallucinate actually. Maybe the question was like medicine one and medicine two for some chemotherapy or something. Okay, but it is trying to like cancel out like or oppose all the English medicine now. So that is hallucination. Since it has confirmed on something, it is fixed to something. So it is more of like in humans we call it narrow-minded, right? So they are
Correct.
strict towards one particular their assumption, and they always go by it, right?
True.
So this is also hallucination. They are not open to the information now. Uh, or let's say it doesn't know how to add 2 plus 2, my model, because it is not a mathematician. It doesn't know how to add 2 plus 2. But whenever a user asking like what is the 2 cube, since it has the tendency to predict the next token, although it can't actually does this mathematical operation, it just says it could be like 7, or it could be 6, or it could be 8. Sometimes the answer could be right. You never know, right? It's more of a guessing game. So this is also hallucination. It should have said that it don't have the capability to calculate, but the tendency of it to answer, to response, made it to answer something, right? Which was like maybe irrelevant. It could be completely nonsense too sometimes. Okay, so that's the gist of hallucination, the different kind of it, with the different examples I gave. Okay. Yes, there is this simple classical example that's been written here. That is, let's just say you are asking LLM to create an URL. Okay, so it actually knows how the URL is and what the URL means. So it will create some URL, so google.com, something, some X and Y, something it is rating, and it feels like it is a genuine website. But if you click on it, nothing opens because it is not hosted. Right? Since it knows how URL are and how usually URL look like, it is trying to create a URL. But that's not how it works, right? Creating a website. So yeah, that's kind of hallucination too. Okay. So yeah, depending on the use case and the severity, this hallucination could be very dangerous. Okay. Let's just say there is an medical hospital one, which has integrated its chatbot. Now it is working on large language model, and some patient given some inputs like maybe the scans, and ask it to like respond, and it says this patient has got cancer, and they actually believe it. This could be like very serious, right?
Right. Yeah.
Right. So depending on the severity, the danger could increase or decrease, right? So
Yes.
that's what the hallucination. We must avoid this at any cost, and we must, as an AI quality engineers, it is our duty to detect hallucinations through different means. Okay.
Hmm.
So we just understood like what hallucination means. So any doubts there?
No, so far clear. And this Olama has been installed.
Okay. So did you run the second command?
No, I just checked
Maybe
it.
maybe you should run it later, because
Mhm.
maybe this call what you are in could be, since it is also I'm sharing my screen and your the video is being processed.
Yeah, yeah, no
It
problem.
could
I'll do it
use
later.
GPUs. That's why.
Yeah,
Okay, that's great. Let me know if there are some problems coming. Okay,
sure, sure.
right. So we understood like how these LLMs are generating the next tokens, and we understood like rough idea on like how these tokens are being decided, and everything, right? How it is
Yes,
working
yes.
basically, how it is simulating the intelligence.
Right, right.
Now we will
It's
understand like we
actually,
have to.
I think these
Sorry.
LLMs have been trained as humans. That's what I
Right,
feel.
right, right.
And
Yes.
because we never know that. how to speak properly. We learn, we get trained in the same way with these also getting trained in every segment.
Exactly. So that's the gist of this deep learning. So machine learning, what it did was we wanted to put up intelligence artificially into machines. Okay, that was the machine learning. It was solving simple problems. While deep learning, we are creating a deep neural networks. Okay, which is in our brain. We are trying to simulate the brain here. Okay, how our brain thinks. And since large language models are also part of it, the transform architecture, correct? They are
Mhm.
also like how our brain learns, how we explore the things and we try to understand, right? Somewhere somebody is sitting in his village and he has like been in his village like for his whole life. He may be against our on the thoughts that could be like different from next his village. Okay,
Hmm.
the only ocean he has seen is his well or his maybe lake. Correct.
Correct.
So yeah, just get back on track with these engineering tools we have. So there are set of parameters. Okay, so there are a set of parameters which we could use, which we could fine tune for any large language model, any large language model. We can fine tune few of the engineering dials. Okay, there are parameters which we could use in order to control the large language model's behavior by a bit. Okay, so it is more of like imagine controlling a person. So if some teacher is there, okay, he may behave differently, but with his friends he may behave differently, right? So that presence is nothing but these engineering dials we are speaking of. Okay,
Okay.
so we have temperature. So this is one of the important ones. Okay, the temperature. So this is a parameter in usually the all the language models. Okay, so how less the temperature is, the creative. In simple analogy, it is creativity. Okay, the creativity decreases depending on how low the temperature is. If it is zero, the creativity is almost dead. Okay, every time you put up an input data, input query, it tries to respond with the output in a similar way. Okay, every time. Okay, so it burns out the creativity. It usually predicts. So when temperature is zero, it may always predict the highest probability token among the available tokens. Okay, so this could be not exactly. So for the same input, you could get different outputs, but the intention of the output could be like almost the same. Okay, it may use different words because internally what it does it's a mathematical calculation again. Okay, so depending on the probability set of words, set of tokens, let's just say probability one for token one, probability two for token two, probability three for token three. Okay, so let's say that it's like 99% or 98%. So here we are dividing by temperature. So depending on how the so yeah, sorry, 1 by t. Okay, so depending on how greater the t is, the net value of these probabilities could increase or decrease. When it is zero, it is kind of like it is multiplied with some zero plus constant. Okay, so the highest probability is always chosen, and the lower probability usually the probability decreases a lot since the t is less. Okay, so yeah, so again, this is mathematics, but we may not need not worry about the mathematics here. So that's how temperature controls what to predict. Okay. So usually
Okay.
for the tasks which involve like a statement, like let's just say uh, it's an maths class, maths answers you want to look at, or the science answers. Okay. There to understand it better, the temperature could be zero, so it always responds back with the exact statements. Okay. But let's say you want to speak about like English. Okay, where the creativity lies, or you want to understand different analogies to explain a science experiment. Okay, there you need some story, right? And the story needs creativity. Okay, there you could
Yes.
increase the temperature, and this with this formula, it allows it allows the greater probabilities. Let's say P1 had like 90% probability initially, and 80% and 70%. Now with the temperature as the temperature increased, it would be controlled like 91%, 89%, 70, some 80%. Okay, the probabilities could change. It could increase or decrease depending on the temperature.
Mhm.
And now the model can choose something like in these two. Okay, or if there are like so many words to be chosen, the probability increased because of the temperature. The model can choose any of this randomly. Okay, and depending on what it chooses, the next word prediction changes, right? So because this becomes the context now, correct? Which we explored some time back. So that's why increasing the temperature could mean the responses could be like varying. Okay, and if you increase the temperature to like lot, like 2 maybe, then the output could be completely irrelevant every time. Okay, so we have to play around with this temperature in order to get the sweet spot where it is creative enough but not nonsensical. Okay,
Okay.
right. So that's temperature. Uh, okay, so we have mentioned like all the three here. Maybe we will complete this and we'll wrap up as of today's session. Okay.
Sure, sure.
So yes, we explored temperature. So let's understand what top P is. Okay. So P means pool actually. Okay. So pool is, so let's just say, uh, so the first token is generated, token one. Okay. Now it has to select token two, and there are list of words, word one, word two, or token one, token two, token three. Okay. There could be like many token in. So it can choose anything among this. Okay. But when this top P is given, this parameter is being provided. Okay. It can decide what is the threshold probability I want to look at. Okay. Let's say you put it as like 0.7 or something. Okay. Then only the tokens which has the probability greater than 70, right?
Mm-hmm.
Uh, Only they could be selected. Now LLM can't select any other. Only among those were those particular tokens with the higher probability. The threshold is 70, right? So more than 70 or 70 could be selected now. So this is the restriction you are adding. Okay. So the analogy, the teacher's presence makes the behavior better, right?
Right.
So the presence of this particular parameter, depending on how friendly the teacher is or how the strict he is, how the students react, how the token is being selected, could be different. Relatable?
Yes.
Okay. So yes, that's why we say it pool, because it is actually pooling what could be the next token, right? Yeah. So if the polling is like the threshold is very less, it could allow like all the available words and tokens. So the next word could be like very different, just like the temperature. If the P is very less, then it could be completely nonsensical words could be chosen. Okay.
Mm-hmm.
Yes. And there comes top K. So this actually specifically mentions. So here it is pooling, right? So top few or depending on the probability.
Right.
So let's just say there are like 100 words, and 100 words has like 70 percent or more probability. Okay. Then all those 100 words could be selected here in the pool, right? So now the model has to choose between like 100 words.
Mm-hmm.
So what top K does is like, unlike pooling here, it actually, let's say K is given like something like 5. Okay. Only the 5 tokens, the top 5 probabilities could be selected here. It could be like 99%, 98%, or 99.9%, all this. Only the top 5 could be chosen. Okay. Let's say K is 50. Then top 50 of these could be chosen. Okay.
Okay.
So here we are basically controlling what the model chooses as the next one. Okay. Because that acts as a context for the next token generation too. right? Where there
Right.
is where like our intelligence is lying. So by controlling this, we're actually controlling the large language model's responses to some extent. Okay. So although you may seem like by choosing k as one, can I always get a same answer because it is always getting like top probability, right? That could be like very easily misunderstood, right?
Right.
So the k, if the k is one, okay, so it always tries to get the topmost token, topmost probability token. So for a single query, let's just say how AI works. Okay, for this
Sure.
query, every time the answer should be same, correct? With this
Correct.
analogy, but it doesn't happen so because the probabilities are not decided earlier. Okay, the probabilities are also decided instantaneously. And let's say a word could have like 99.9% probability. Okay, the other word could have 99.8%. So depending on this calculation, since these models are black box models, the calculation may be inversed. In the second iteration, when you provide the same statement, the probability of the second model, which came like 99.8 earlier or 98 earlier, okay. So this could be considered as like 99.99%. Okay, and the first word which came earlier could be considered as like 99.89 second word. Okay. Since GPUs can't actually calculate every percent of it for every possible words, they usually round off. And here, this could be difference. Okay. Since it differs, the word chosen could be different and the statement could be different. But most of the time, the intent of the statement remains the same. Okay.
Right.
Right. So yeah, so when I read it first time, also that was the question I got. Like by controlling this, we are actually controlling the non-deterministic character of the LLM, but we are still not controlling it because the non-deterministic character is the fundamental characteristic of LLM. Okay.
Hmm.
Yes. So yes. Any doubts still now?
No.
Sure, then maybe we will wrap up the session for today. We have like few things to explore. Maybe since you are installing it now, later we can just explore this and go with the second module. Okay.
Sure. Sure.